The substances, phenomena, and objects you'll see in this episode not only spark the imagination, but also make the entire scientific world frown in disapproval.
After all, they encroach on the most sacred thing, the laws of physics, which are supposed to explain reality. But often, such explanations don't stand up to any criticism. So, get ready to be amazed.
The most astonishing things, as usual, are at the end of the episode. Let's go. What comes to mind when you hear molten lead? Well, at the very least, it's hot. Some people might have even heard about medieval torture involving it.
The melting point of lead is relatively low compared to other metals. It's just 327.5 degrees.
For example, aluminum melts at 660 degrees. But is it possible to put your hand in it without pain? It turns out it is.
You just need to wet your hand before dipping it into the lead. The water instantly evaporates and creates a safety cushion that prevents burns. Only for 1 second, but still. These amazing shots are possible thanks to the Leidenfrost effect. It's the same effect that makes a drop of water dance on a hot frying pan. Let's move on. Chinese scientists recently managed to trick the laws of physics. They learned how to control the bounce of a falling drop and spin it in the direction they want. The researchers applied a fluorinated non-stick coating to aluminum plates. It's similar to the kind used in making frying pans. And they partially exposed them to ultraviolet radiation. The areas treated with ultraviolet rays retain moisture, while the zones that are not exposed to this radiation repel it.
Thanks to this, the droplet spins in any direction, seemingly defying all the laws of physics.
Its rotation speed is, just think about it, 7,300 revolutions per minute. Well, you might wonder who needs spinning droplets. They can actually have quite practical applications. For example, in the production of self-cleaning surfaces. The impossibility of creating a perpetual motion machine is explained by the first and second laws of thermodynamics. Nevertheless, the line of inventors will never end. Starting from 1775, when the Paris Academy of Sciences stopped considering perpetual motion machine projects, many of these perpetual motion projects still, contrary to the laws of physics, have the audacity to work. For example, the battery of the Romanian engineer Nicolae Vasilescu Karpin, who invented his device in 1950. His battery still works today and has been running for 71 years and is kept in the National Technical Museum of Romania. Although the design of this battery was patented a long time ago, scientists still do not know exactly how and on what principles this device works. Karpin's battery has a scientific name, a thermoelectric battery operating at a constant temperature. But that doesn't really explain anything to anyone. The existence of this battery is considered an unscientific fact in scientific circles, because a perpetual motion machine cannot exist from the point of view of modern science. The prototype consists of 2 galvanic cells. They drive a galvanometric motor and a switch that, with every half turn of the motor, closes the circuit and then opens it again. The rotation time of the motor is carefully selected so that it is enough for the galvanic cell to fully recharge, while also reversing its polarity. According to the inventor's idea, the purpose of the motor and the plate was only to demonstrate that the batteries actually continue to constantly generate electricity. The motor and the plate are not needed for anything else. Another unique technology that violates the laws of physics was created by scientists at the Argonne National Laboratory in Illinois. It allows solid objects to be turned into sponge-like structures. The researchers took zinc cyanide, which is used in metal electroplating, and placed it in a diamond anvil cell. Then they applied a substantial pressure of 9 to 18,000 atmospheres. As a result, the solid material turned into a sponge-like structure, which, from the perspective of modern physics, is nonsense. By placing different liquids around the material under pressure, the scientists managed to identify 5 new phases of matter. The different types of liquids determine the shape of the pores in that sponge-like structure.
This is the first time that under the influence of so-called hydrostatic pressure, it was possible to turn a solid material into a porous structure. It's roughly the same as squeezing a stone like a sponge.
Moreover, the structure itself, the structure of the sponge, is very strong.
Another violation of the laws of physics is the Tippe top. The spinning top, a children's toy, has been known since ancient times.
Even though it's impossible to make a stationary top stand on its pointed end, a spinning top can remain upright for several minutes.
Spinning tops, like other rotating bodies, acquire what is called angular momentum. Angular momentum reproduces the rotational force.
It causes the axis of the spinning top to maintain its tilt angle relative to the vertical and to make oscillatory movements. In physics, this is called precession.
The Chinese top, or Thomson's top as it is also called, works a little differently. The top is spun by its stem. Once it starts spinning, the top loses stability and its stem tilts away from its original vertical position. As a result, the top flips over and continues to spin steadily, but only on its stem. But what's wrong with the Tippe top? It was developed by the Japanese scientist Tadashi Tokieda. It looks like just a piece of some pipe. However, this little tube has puzzled quite a few scientists.
If you spin this top in one direction, it will eventually stand up on its stem, just like a regular Chinese top. But if you spin it in the other direction, that won't happen.
So far, scientists have not been able to explain such an unusual property of this device, despite the undeniable Newton's laws and other patriarchs of physics. All right, we've played enough. Now let's move on to more serious things: space flights. Nowadays, science has made significant progress in creating space probes and launching all sorts of things into near-Earth space.
But to start exploring space more actively, we need to be able to travel through it quickly enough. For that, a warp drive would be quite suitable.
Its principle of operation is that it compresses space and time in front of the shuttle and expands it behind it. That is, a ship equipped with such an engine will distort space, shortening the distance to its destination. During the flight, the ship will hover in a kind of bubble.
It sounds like a banal and not very well thought out plot of a sci-fi blockbuster. However, that's not the case.
NASA and the China National Space Administration have already made significant progress in this area. Well, at least they've started working on it. They have conducted successful experiments in creating a device that reflects microwaves within the space around it and does not require fuel. According to NASA representatives, this electromagnetic drive is capable of delivering a spacecraft with astronauts to the moon in just a couple of hours, or reducing the travel time to Mars to 70 days. It sounds impressive.
But it will probably be a long time before we see what comes of all this. After all, before breaking through space with bubbles at the airfield,
We first need to at least understand what this very space we're trying to manipulate actually is, and that's where science has problems. About 90% in fact. Take our very best knowledge about gravity, apply it to the rotation of a galaxy, and flush it all down the toilet. Because that knowledge just doesn't work here. According to the accepted theory, galaxies should fall apart. Galactic matter rotates around a central point because its gravitational pull creates centripetal force. But there's not enough mass to account for the observed rotation in galaxies.
The best answer physicists could give was to assume that there is more matter in the universe than we can observe.
The problem was that no one could explain what this dark matter actually is, because this phenomenon can't be explained by the existing laws. Astronomical observations indicate that dark matter must make up about 90% of the mass of the universe, but we know almost nothing about this 90%. Despite this, scientists are still trying to study dark matter, and the results of these studies are pushing global science further away from the familiar laws of physics.
As the general theory of relativity imposed on the scientific world states gravity distorts space and time.
Today, this theory successfully explains the expansion of the universe, the existence of black holes,
and the movement of light from distant stars. But technical capabilities are growing and factual information is accumulating, constantly throwing a wrench into the convenient system that suits everyone.
Thus, a group of scientists from the Institute for the Physics and Mathematics of the Universe in Japan, led by Chaki Hikago, created a 3D map of dark matter throughout the history of the universe based on the analysis of images of more than 1 million galaxies. They analyzed images of 10 million galaxies taken with the 8-meter Subaru telescope equipped with an 870-megapixel camera.
The image is certainly beautiful, but here's how the Japanese scientist cautiously put it. If further data show that we are indeed correct, then it means that something is missing in our current understanding of the Standard Model and general theory of relativity.
Well, since we're talking about dark matter, let's talk about black holes. By the way, we have a separate episode about that. We recommend checking it out. But right now, here's what I want to say.
Not so long ago, the Hubble Space Telescope captured an unusual black hole in the center of a galaxy in the Virgo constellation under this number.
The thing is, the light coming from it doesn't match the size and type of the object. It turns out that this black hole, by its very existence, contradicts the known laws of physics. Most large galaxies have a supermassive black hole at their center, but some revolve around lighter intermediate mass objects. And this galaxy is centered around one of the less massive black holes, but the spectrum of light coming from it contradicts everything we know about objects of this type.
In short, the scientists' calculations don't add up, and they're in a bit of a panic. At this rate, more and more facts, even from academic scientists themselves, are piling up to the point where it's becoming harder and harder to stick to the commonly accepted Einsteinian paradigm.
By the way, we also recommend watching our previous episode about Einstein.
It looks like the scientific elite will soon have to admit that what worked and was so beneficial for decades has long since broken down, and it's time to stop misleading people. But how soon will that actually happen?
Anyway, we hope you enjoyed the video. Let us know in the comments which phenomena and objects you'd like to learn more about, and we'll think about how to make it happen. See you next time.